So you've been introduced to the idea of halogens and hydroxyl groups as two different types of functional groups, but what I would like to introduce in this video is a new type of functional group and one of the molecules that contains it. And it is the first time we're actually going to see a double bond that's connected to something other than carbon. So what we're going to be talking about is called a carbonyl, or sometimes called carbonyl group. And it is when you have a carbon double bonded to an oxygen. And this shows up in a few different functional groups, but we're going to focus in this video on the ketone. So a carbonyl group is just a carbon double bonded to an oxygen. It is actually a pretty common functional group, and it lends itself to a lot of chemical reactions. It also shows up in several different molecules depending on its location, and we're focused in this episode about ketones. So ketones are when the carbonyl carbon is actually attached to carbons on each side. So down here, this would be an example of a ketone. You see you have your carbonyl carbon in the center, and attached on either side is carbons. One of the big misconceptions I find about ketones is people think they have to be in the middle. They don't have to be exactly in the middle. They just have to be surrounded by two carbons. What that means is you can't have a hydrogen attached to one side, because that's actually an entirely different molecule, which we'll cover later. But a ketone has to have two carbons on either side of the carbonyl carbon. So now that we know what it is, let's take a look at how we name it. So when it comes to naming a ketone, you're going to find that this is a pretty similar set of rules when it came to alcohols. You're going to name the parent chain, but the parent chain must contain the ketone group. So you really have to make sure you find that ketone group and find the longest chain of carbons that actually contains it. Then you need to change the E ending. So remember, this came from the ANE, ENE, or YNE ending, and we're changing that last E. And in a ketone, it becomes ONE. So you can get things like propanone, and that's how we know it's a ketone. The ketone also has to get the lowest number you can possibly give it. So you're going to number your chain and make sure that that ketone, that carbonyl carbon, gets the lowest possible number. From there, you just name your substituents exactly like we have with all of our other compounds, and that's all we have to do. So now that we know our naming rules, we know what what ketones are, let's take a look at some examples and let's name them and draw them. So we're really just going to start simple. We're going to start with just a straight ketone, and I know it's a ketone because I see this double bond to an oxygen right in the center of this chain. So it could also have been here or here, but it is surrounded by two other carbons, which makes this a ketone. So now that I know I'm dealing with a ketone, we want to figure out what is our parent chain. So how many carbons make up this chain? 1, 2, 3, 4, 5. So we're dealing with a pent. Single bonds tell us AN, and the ketone group tells us ONE. So this would be some type of pentanone. Now, with pentanone, we need to also number so that we can figure out where that ketone group is. So we have carbon number 1, 2, 3, 4, and 5. This is on carbon number 3, and so we get 3 pentanone. So you can see we use that ONE ending to show that it's a ketone, AN to show that there's single bonds, pent to show that it's a 5-carbon chain with that ketone, and the 3 tells us where the ketone is. Remember, the whole name should tell you a story, and that's exactly what this is doing. So now that we've done something simple, let's try something a little bit more complex. So here we're dealing with a little bit larger molecule, a little bit more complex things happening, and we want to first of all find our longest chain that contains our ketone. Well, I guess first thing you should probably really do is identify that it's a ketone. And it is a ketone because of that double bonded oxygen connected with carbons on either side of the carbonyl carbon. So now we want to find our longest chain of carbons. So if we're counting, we have 1, 2, 3, 4, 5. If you were to go this way, you get 6. But we go 1, 2, 3, 4, 5, 6, and 7 going this way. So we're dealing with some kind of hept. That's going to be our parent chain. And we are dealing with only single bonds, so AN. And then we have an ONE ending to show that we have our ketone. Now we also need to number this ketone. So we want to give it the lowest possible number. If you were to count from here, you'd go 1, 2, 3, 4, 5 versus 1, 2, 3. So that's how we're going to number this. 1, 2, 3, 4, 5, 6 down here, 7 over there. So you can see we have 3 heptanone, but now we have this branch that's sticking off over on the side. So in the 5th position, the 5th carbon, there's a 1 carbon branch. So we're dealing with a methyl in the 5 position. So this molecule is 5-methyl 3-heptanone. Okay, so now we see that we have something a little bit more complex going on. Okay, so in this example, what we want to do is, first of all, recognize we're dealing with a ketone. We have this ketone because of the double bonded oxygen. We also have a cyclo. So we are going to name that very first. We have a 6-carbon ring, which we called cyclohexanone. And to show that it's a ketone, cyclohexanone. Now, when it comes to the numbering system, this is considered the priority group, and the priority group always gets the lowest number. So that means that ketone is going to get the number 1. And now you want to make sure that you number this in a way that's going to give you the lowest possible set of numbers. So 2, then 3, and you'd work your way counterclockwise. So we get this part here, the cyclohexanone. Just want to fix this up so it's easier to read. We know that cyclohexanone, the ketone, is in the 1 position. We also have this bromine. And so bromine alphabetically comes before methyl. So at the beginning of the name, we are going to have 3-bromo, 2-methyl, 1-cyclohexanone. So you can see, really when it comes to naming ketones, it's not overly complex. We're really just adding that ONE ending and identifying it with its number in front of the name. Any substituents, they're going to come before that number. And if it is in a ring, making sure that we identify that with the cyclo prefix. So hopefully this helps give you an understanding of what ketones are and how to name them. And I'll see you next time.